So we are at our last session of the day. It's almost time, well, to stay home because you're probably watching this from home. And our next talk will go about automated machine learning. Now, what is automated machine learning? We've already looked at it a little bit, but one of the benefits of automated machine learning, is that we have interfaces for all kind of skill levels. So that way we can democratize AI. So if you are used to writing code in Jupyter notebooks with Scikit, for example, well, then you can do that. If you want to do sophisticated deep learning and you want to use TensorFlow, well, then you can also still interact with automated and machine learning services. But then the other aspect is machine learning is for users who are needed some machine learning, deep learning expertise, and they don't really have the perfect expertise in that. Well, then they can still make use of automated machine learning. Now, let's say we have a problem of how much a car is worth, which we want to solve using machine learning. Now, our approach to machine learning framework is quite simple. We give customers the flexibility to choose their deep learning framework without getting locked on a specific framework. And to help with this, we've created a community project in partnership with Facebook that allows customers to train in one framework and use another one for inference. That's what we've discussed before also already. That was called Onyx. Now, through the whole day, we've been trying to build machine learning models in very easy ways. We used Custom Vision API, for example, to build something quickly and very well built. But at the end, model creation is a very complex process where we have to experiment with different model architectures and tune hyperparameters to see which gives the best accuracy or performance metrics. So by trying different combinations, you might, well, I hope you will find the best one that suits you. And once you found the best one, you have the full Azure machine learning pipeline to reproduce it and so onwards. But this makes it all easy. Now, let's move to machine learning. So model creation is typically, So let's say we have a problem of how much is the cart worth, which we want to solve using machine learning. What we want to do now is by making use of automated machine learning, which is an easy way of building a machine learning model without having too much knowledge of machine learning. Now, if we think about the time that is needed to create a model, well, it's a heavy time consuming process, because the first things we need to do is, okay, what features are we going to use? What columns of our data set, you could say. And then what kind of algorithm do we need to use? And we already looked at now I'm going to say it again, the machine learning cheat sheet, where depending on what question you have, you already have a little predefined list of typical algorithms that you could use. And then based on your algorithm, you need to give it some parameters. So all of this is really time consuming. So first you need to select which features do you want to use. Then you want to choose, okay, I want to have, for example, a gradient boosted. Then this one has specific parameters. We will configure that and we get a model with 30% prediction rate. So it's only 30% correct, which is actually not so good. Now, what we want to do is, okay, we want to try it. We put this aside and we try it for another model, nearest neighbor. And then again, we had another prediction rate, 50 accuracy rate. So now we have 50%. Okay, that's better. But this is an iterative process. And with automated machine learning, actually, we want to try and automate all of this. And we want to try as many algorithms as possible. And then we want to see, of everything that we've tried, which one is the best. So automated ML really helps to expedite the process by intelligently does the exploration phase by using machine learning for you. So it intelligently tests multiple algorithms for the dataset in parallel using the Azure Machine Learning compute that meets your goals and identifies the best model as the output. So it will go over all different elements. This makes machine learning much more accessible for wider audience. Also, even for advanced data scientists, this can be a great tool of exploration to accelerate the model development. Excuse me. Now, before when we discussed automated machine learning, it's a good way to start to figure out what our baseline model can be, and then based on that we can optimize it to our specific needs. Now, I don't want to talk more in detail about this, and I just want to go straight to the demo. So in the demo we were going to set up an Azure Machine Learning workspace, and then we're also going to do all the rest and work with that data set of the car price. So let's have a look. Now we are in our portal, and what we want to search for here is machine learning. You can also look for it here in the search bulk. So we click on machine learning, and then we click add. Now here you give it a name, usual subscription, resource group, the location where you want to have your resources stored, and a workspace edition. It's interesting to know, if you open the details of the workspace editions, so we have basic and enterprise, where the basic level doesn't have so many web interfaces. So with enterprise you have the studio web experience, so you have some extra forecasting capabilities, you have a larger data support, and you have interpretability and UI, and not in code. And then there's also some differences in the machine learning pipelines, and so on. So depending on your use case or what you want to do, you'll need to select which one you want. Of course, based on top of this, you still need to make a selection of what compute you want to add. Now, I've already created one. So when we go to, I'll just go here to the start. Let's get this running. Okay, just need to select my created workspace. Zoom a little bit out. Okay, so what we want to do now is create an automated machine learning experiment. So we have here automated ML on the left side. When we click on it, we can create a new automated ML run. Once we've clicked on this, it will ask us to create a data set. Let's create a new one from a local file. So from here onwards, we can just upload a file from our computer, or we can use it from a data store that we've configured before. It can also be a file that is just stored online, or from an open data set, maybe from some APIs. Now we'll just upload a file now. We give it a name, so car price demo data. We say next. And then we say browse because we want to select our file. I'll just we say car price, open. We do next. So the file is getting uploaded now, and it's even already being checked in the background. So what we see now here is an example of our data. This is going to be a bit more visual. So we have all our columns here, but as you might notice, our column names are not taken from the headers, so we just need to set that. And then again, depending on the data that you've loaded, you need to select if you have another delimiter or if you use different encoding. So once this is set, we click next. In this part, we see all the columns, and we actually can say already we want to ignore specific columns out of our data set. That's, for example, we are not interested in the horsepower to be part of the data set to train our model. Now, if you're sure about certain columns that they're not going to be interesting at all to generate a training model, then you can already leave them out. During the AutoML process, the AI that is building the machine learning model will actually try out different features and might leave out some already. So it might not take all of them into account. So we will just leave all of it like this. So we click next. So now we have just some details about our file, and we click create. So first step, data gathering, is done. If we do this in a Jupyter notebook, which is perfectly possible, you can also run and start Azure Automated ML through Jupyter notebooks. You could pre-process your data, for example, before, and then send it to your automated ML run. So we have our data set here now, car price demo data. We choose it, we click next. Just give it some seconds to load. Now we need to give it an experiment name, car price experiment. And now we need to choose what column you want to predict. So our target column in this case is our price. We need to select where you want to run your machine learning algorithms on, so which compute. I have one already, but let me also show you how you can create a new one. So you give it a name, my compute 2, for example. Your region will depend on where you've set up your region of your workspace. And then you have your virtual machine type. So again, I just need to remove my spaces here. So again, this depends on what kind of processing you want to do. If you think you're going to use more algorithms that need a lot of processing power, then maybe you need to go through GPU and not to CPU. But that's up to you. For this case, we will just leave it on CPU machine types. As discussed before, you can choose if you want to have dedicated virtual machines of low priority. If you have the time and you just want to let your training processes run for longer times, then yeah, you can choose low priority. But again, that depends on business case to business case. So we'll just, in this case, we'll keep it on dedicated to have it a bit more faster. Now, the second option is to select what kind of virtual machine we need. So we've already selected that we just need CPU optimized, but now we can still have more detailed how many cores do you want, how many gigabytes of RAM, and how much hard drive you need. So, and then the next one is, as discussed also before, the minimum of nodes and the maximum of nodes. Keep in mind, if you're running many different processes or running different training processes, that if your nodes are on 0, when all the nodes are shut down, it needs to recreate your cluster and needs to restart it. So that takes some time. Keep that in mind. So if you leave it on 1, it's always running, but of course there's a cost linked to it. And this is then the idle seconds before scaling down. So if your environment, if you're not training any data for more than, well, if nothing is happening after 120 seconds, then the cluster will automatically scale down to, now in this case, to a minimum of 0 nodes. So then your cluster is fully switched off. I'm not going to create this one because I've already created one, so my compute. Then we click next. Oh, I need to give it a name. Experiment 2. Now we need to say to the AutoML what question you want to answer. And we have classification. Do we want to link group by or data in specific categories? Do we want to do regression? Do we want to predict what a certain amount could be? Or do we time series forecasting? What is our sales going to be for the next 2-3 weeks, for example? If you want to do mirror models on like for the custom vision and so on, then this is not the place for it. Then you go to custom AI. So we'll choose in this case regression, and we click finish. Now what is done? Actually, it's built a pipeline for you with all the different types it wants to try out, all the different algorithms with all the different parameters, and mixing up with different features or columns. Now, of course, we're not going to wait for this one. If we go to automated ML back, I've already created a run where we see that it has been finished. We see the different models that it's tried to run, and also what the Spearman correlation is. Now, it only created one model because it started up the cluster, and then it will start trying elements. Now, normally you would have here a full list of many different items, of different algorithms that it tried. Now, if we click on the algorithm, we will see more details about it. So we can visualize it, how it's doing. We can get some explanations about it, like how items are linked to each other, which is very important because imagine you're building a model to see if you can give someone a loan or not. Well, it would be dangerous if you cannot explain why that person did not get a loan. So this is something you really need to look into. And then, of course, we have the logs of everything that has happened. And as output, we have also the scripts that got run. Now, if we go back to our model deployment, you see here the download button. So when we click on this, it will generate a zip file that contains our machine learning model. Now, what we also see here next to it is the display button with the deploy text. When we click on deploy, we can automatically already configure everything and send to an Azure Kubernetes system or a container instance. So let's do this. Let's call it the name model X. Hey, I just need to put it in small capitals, small letters, lower capitals. In this case, I'll just use Azure Container Instance. We can enable or disable authentication. So if your API needs to be run through some authentication before it can be used, we have some advanced parameters that we can set up, like enabling application insight and so on. We'll just leave it like this, and we click deploy. So in the meanwhile, now everything is getting deployed. Now, as you've noticed, well, we didn't use any code. We need to maybe understand a bit of what kind of question we have to select what kind of task you want to do. But that's it. Now, our deploy status, we can look at it now through your endpoints part here. And we see here we have a consume. It's still setting it up, so just give it some more time. So our model So our model has successfully deployed. We see the deployment state is healthy. We see on what kind of computer type that we've selected before. And also, how much CPUs it's consuming and memory. Now how can we call it? Well, if we click on the consume button, we get the REST endpoint. So this can be used within your web application, as we saw with Tailwind trading, but could be a mobile app or so on. Now, if you would like to use this model within another machine learning project, well, then we can just go to models, and through the SDK, the Python SDK, we can call this model also to be able to reuse it or to extend it with other machine learning models. Well, that was it for today. We've discussed quite a lot of different things, but let's go over a recap and bring everything a little bit back into mind so we can use it also in the future. Now, in our first session, we used cognitive services, and actually we used two of them. We used the cognitive search to have a quick way to search through unstructured documents. And remember your boss that came to you that he had removed the database with hundreds of thousands of PDF files that were all invoices. We combined that by adding extra skills to it with the form recognizer. Now, after this, in our second session, we talked about the different cognitive services that are there. We looked into custom vision API, and there we noticed that we need to keep in mind the 80-20 rule. See how with that 80% of the questions might be able to ask with existing items, and that the rest of it, the 20% that are sometimes very important, we need to find solutions for it with something we built custom. Now, then we looked into how we can build machine learning models faster than you think. We looked a little bit in O2ML at that time, and then we started looking also in how to build the DevOps process of preparing your data, training your data, registering your model, and actually bringing it in production in a whole iterative way through Azure Machine Learning pipelines and Azure pipelines. And then we finished up today with a more depth demo of automated ML. I hope you all enjoyed this training day. I hope you learned a lot. I know it was a lot of information in the last 4 hours of video material. If you have any more questions, I can imagine you probably have. Well, then don't hesitate to contact me at any time that you want. Send me an email or send me a Twitter message. I'm here available for you. So thank you for joining me in this day, and I hope one day we can see each other for real. So you have seen me a lot of the time, but I don't know who's behind this screen. So thank you very much and have a nice evening.